Okay, in this video we're going to look at how to compare box plots. So quite often you're given in a test two box plots to compare, and whenever you're comparing them I would recommend looking at these two things. I would recommend looking at comparing their medians. Okay, so seeing which one is higher or lower on average, so that then lets you know maybe if it's a test who performed better, or if it was looking at the heights of people who on average are higher. But look at the medians, and then also maybe look at the lower quartiles and upper quartiles as well. But the medians is usually my first port of call whenever I'm comparing box plots. The second set of information I would compare, if I'm comparing the medians to begin with, or the lower quartiles and upper quartiles to begin with, I then would compare the interquartile range. This is a measure of how spread out they are. Okay, so compare the interquartile ranges to see which set of information is more spread out. Because if they're more spread out, it means they're less consistent. So for instance, if a class has got a large interquartile range in a test, that means that obviously we're less consistent in the test. Now, whenever you're comparing box plots, they're usually going to be quite wordy questions. So you're going to have to use sentences in your answers. I would recommend using this thing from English, which is PEE, which is point, evidence, explain. What's your point? Back it up with evidence from your box plot, and then maybe explain it a little bit more, and then do that for both of the two things you're going to compare. So this question says the box plot showed the distribution of marks in an English test and a maths test for a group of students. So as you can see, the marks in maths and English go from 0 to 60, and then we've got our box plots. We've got the English one and the maths one. Now straight away I can see that the English students perform better on average than the maths students. The reason I can see that is that the median for English is much higher than the median for the maths. The upper quartile for the English is higher than the upper quartile for maths, and the lower quartile for English is higher than the lower quartile for maths. So they performed a lot better on average than the maths students, and I'm going to write that down in a second in words. Okay, well, I'll write it down obviously in words. The next thing that I noticed is that the English students seem fairly, the middle 50%, okay, the interquartile range looks slightly more spread out than the maths students. So the English students performed better, but they're a little bit more inconsistent than the maths students, okay, they're less consistent because they're slightly more spread out than the maths students, okay. So what I'm going to do is I'm actually going to write that down now. Okay, so let's have a look. So the first statement I made was the results in English were better than in maths because the median, lower quartile and upper quartiles were all higher in English than higher in English. So if you notice that the lower quartiles were higher in English, the median was higher in English, and the upper quartile was higher in English, so therefore the results were better. The students performed better on average. The other statement I made was the maths results are more consistent. So they're worse, but they're more consistent as the interquartile range is smaller than the English interquartile range. In other words, they're less spread out because the interquartile range is smaller than this interquartile range. Okay, so the English students were less consistent. The maths students were more consistent, but again, the English students performed a lot better than the maths students.